In this video, I will explain how the relationship between zeros and coefficient of cubic polynomial is derived. After that, I will explain few sums related to that. These sums are from NCERT book as well as from NCERT Exemplar. I am going to explain relationship between zeros and coefficients of a cubic polynomial. First, I'll write what is cubic polynomial. Cubic polynomial is a polynomial of degree 3 is called a cubic polynomial. For example, x cube plus 4x square plus 3x plus 2, x cube minus 4x plus 5. General cubic polynomial. General ax cube plus bx square plus cx plus d, where a is not equal to 0, is called the general cubic polynomial. Now I'll explain the relationship between coefficients and the zeros. So a is a coefficient of x cube, b is a coefficient of x square, c is a coefficient of x, d is a constant term. And now I'll explain zeros of a cubic polynomial. Let alpha, beta, gamma are the zeros of a cubic polynomial. Then x minus alpha, x minus beta, x minus gamma are the factors of the cubic polynomial. So fx, polynomial fx will be written as k x minus alpha, x minus beta, x minus gamma. So fx is equal to k multiply x minus beta with x minus gamma. I'll have x minus alpha, x square minus beta plus gamma x plus beta gamma. Now multiply these two brackets. I'll have k x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta and gamma. Now multiply this k. After multiplying k with this bracket, I'll have kx cube minus k alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. So I have now ax square plus bx plus cx plus d is equal to kx cube minus k alpha plus beta plus gamma x square plus k alpha beta plus beta gamma plus gamma alpha x minus alpha beta and gamma. And now I have ax cube plus bx square plus cx plus d is equal to kx cube minus k alpha plus beta plus gamma x square plus k alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. Now I'll compare the coefficients of left hand side with the coefficients of right hand side. So a and k are the coefficients of x cube on both sides. So a is equal to k. And b is equal to b is a coefficient of x square on left hand side, and minus k alpha plus beta plus gamma is a coefficient of x square on right hand side. So b is equal to minus k alpha plus beta plus gamma. And similarly, c is equal to k alpha beta plus beta gamma plus gamma alpha, and d is a constant term and minus k alpha beta gamma is a constant term on right hand side. So d is equal to minus k alpha beta and gamma. So write minus b upon minus k is equal to alpha plus beta plus gamma, and instead of k write a. So I'll have minus b upon a is equal to alpha plus beta plus gamma. Similarly, c upon k is equal to alpha beta plus beta gamma plus gamma alpha. Instead of k write a, so you will have c by a is equal to alpha beta plus beta gamma plus gamma alpha. Similarly, d upon minus k is equal to alpha beta gamma, and this is equal to minus d upon a is equal to alpha beta gamma. It means we have three relations now. First is alpha plus beta plus gamma is equal to minus b by a. It means sum of zeros is equal to minus coefficient of x square upon coefficient of x cube. Second is alpha beta plus beta gamma plus gamma alpha is equal to c by a. It means sum of product of zeros taken two at a time is equal to coefficient of x upon coefficient of x cube. And the third relation is alpha beta gamma is equal to minus d upon a. It means product of zeros is equal to minus constant term upon coefficient of x cube. Now my next question is, verify 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial 3x cube minus 5x square minus 11x minus 3, and verify the relationship between zeros and the coefficients. Let me explain the statement. First I am to verify 3 is a zero of this polynomial, minus 1 is a zero of this polynomial, and minus 1 by 3 is a zero of this polynomial. So afterwards I'll verify the relationship between zeros and the coefficients. Now to prove 3 is a zero of the polynomial fx is equal to 3x cube minus 5x square minus 11x minus 3, prove f3 is equal to 0. Now fx is 3x cube minus 5x square minus 11x minus 3. Instead of x, write 3. So f3 is equal to 3 cube minus 5, 3 square minus 11 into 3 minus 3. This will come out to be 81 minus 45 minus 33 minus 3, which is equal to 81 minus 81 is equal to 0. So it means f3 is equal to 0. So it implies 3 is a zero of the given polynomial. Similarly, we will prove for minus 1 and minus 1 by 3. So fx is equal to 3x cube minus 5x square minus 11x minus 3. Write minus 1 instead of x. You will have f minus 1 is equal to 3 minus 1 cube minus 5 minus 1 square minus 11 minus 1 minus 3. It means this is equal to minus 3 minus 5 plus 11 minus 3 is equal to minus 11 plus 11 is equal to 0. So f minus 1 is equal to 0. So it implies minus 1 is a zero of the given polynomial. Again write the polynomial fx, which is equal to 3x cube minus 5x square minus 11x minus 3. So instead of x, write minus 1 by 3. So f minus 1 by 3 is equal to 3 minus 1 by 3 whole cube minus 5 minus 1 by 3 whole square minus 11 minus 1 by 3 minus 3. So when you solve this, you will have 3 into minus 1 by 27 minus 5 into 1 by 9 plus 11 by 3 minus 3. This is equal to minus 1 by 3 minus 5 by 9 plus 11 by 3 minus 3. You will have 9 in the denominator as a LCM. You will have minus 3 minus 5 plus 33 minus 27, and when you solve this you will have 0 upon 9 is equal to 0. So this again shows minus 1 by 3 is a zero of the given polynomial. Now I will prove the relationship. So write the cubic polynomial 3x cube minus 5x square minus 11x minus 3. Here coefficient of x cube is equal to 3. Coefficient of x square is equal to minus 5. Coefficient of x is equal to minus 11. And the constant term is equal to minus 3. So let alpha, beta, gamma are the zeros of the polynomial. So here alpha is equal to 3, beta is equal to minus 1, gamma is equal to minus 1 by 3. So write alpha plus beta plus gamma, which is equal to 3 minus 1 by 3 is equal to 2 minus 1 by 3. Take 3 as a LCM. So 6 minus 1 is in the numerator. You will have 5 by 3. So write minus b by a, which is equal to minus 5 by 3, which is equal to 5 by 3. So this implies alpha plus beta plus gamma is equal to minus b by a. So you can also say sum of the zeros is equal to minus coefficient of x square upon coefficient of x cube. Now verify the second relationship. Write alpha beta plus beta gamma plus gamma alpha, which is equal to 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3. You will have minus 3 plus 1 by 3 minus 1, which is equal to minus 4 plus 1 by 3. So you take 3 as a LCM, you will have minus 12 plus 1 in the numerator, and when you solve it, you will have minus 11 by 3. Write c by a, which is equal to minus 11 by 3. So this shows alpha beta plus beta gamma plus gamma alpha is equal to c by a. So you can also write sum of product of zeros taken 2 at a time is equal to coefficient of x upon coefficient of x cube. Now verify the third relation. Alpha beta gamma is equal to 3 into minus 1 into minus 1 by 3, which is equal to 1, and minus d by a is equal to minus 3 upon 3 is equal to 1. So this shows alpha beta gamma is equal to minus d by a. So it implies product of zeros is equal to constant term upon coefficient of x cube. If the next question is, if the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a and a plus b, find a and b. Let alpha beta gamma are the zeros of the polynomial x cube minus 3x square plus x plus 1. So we will take alpha as a minus b, beta as a and gamma as a plus b. So write alpha plus beta plus gamma, which is equal to minus coefficient of x square upon coefficient of x cube, which is equal to minus 3 upon 1, which is equal to 3. So alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x upon coefficient of x cube. So coefficient of x is 1, coefficient of x cube is 1. So we will write 1 upon 1, which is equal to 1. Write alpha beta gamma, which is equal to minus constant term upon coefficient of x cube, which is equal to 1 upon 1 is equal to minus 1. So I have alpha plus beta plus gamma is equal to 3. So write, instead of alpha write a minus b, instead of beta write a, instead of gamma write a plus b, which is equal to 3. So cancel b and minus b. We will have a, 3a is equal to 3. So value of a is 1. Now take the help of this third relation. Alpha beta gamma is equal to minus 1. Instead of alpha write a minus b. Instead of beta write a. Instead of gamma write a plus b is equal to minus 1. Now substitute the value of a, which is equal to 1. So this becomes 1 minus b, 1 plus b is equal to minus 1. So a minus b, this is the formula. A 1 minus b and 1 plus b, it is equal to 1 minus b square, which is equal to minus 1. So take b square on the right hand side and minus 1 on the left hand side. You will have 2 is equal to b square. 2 is equal to b square and value of b is equal to plus minus under root 2. My next question is, given that the zeros of the cubic polynomial x cube minus 6x square plus 3x plus 10 are of the form a plus b, a plus 2b for some real number a and b. Find the value of a and b. Also find the zeros of a polynomial. Now here students have a very genuine problem. They compare the cubic polynomial with the general cubic polynomial ax cube plus bx square plus cx plus d. Then they say a is 1, b is minus 6. Substitute these values in a plus b, b and a plus 2b. We should get the answer. But here problem arises because zeros are given in terms of a and b. So we should be very careful while solving this problem. Now let me solve this problem. Let's start this. Let alpha, beta, gamma are the zeros of the polynomial x cube minus 6x square plus 3x plus 10. Take alpha as a, beta as a plus b and gamma as a plus 2b. Now write the relationship. First relation is alpha plus beta plus gamma is equal to minus coefficient of x square upon coefficient of x cube. That is equal to minus 6 upon 1, that is equal to 6. So I'll advise students to write the relationship in this way. Second relation is alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x upon coefficient of x cube, which is equal to 3 upon 1, that is equal to 3. Third relation is alpha beta gamma is equal to minus constant term upon coefficient of x cube, that is equal to minus 10 upon 1, that is equal to minus 10. So write the first relation. Alpha plus beta plus gamma is 6. Substitute the value of alpha, beta and gamma. You will have a plus b, a plus 2b is equal to 6. So 3a plus 3b is equal to 6. Take 3 common. You will have a plus b in the bracket and is equal to 6. So a plus b will come out to be 6 upon 3. So a plus b is equal to 2. Here you find the value of a in terms of b. Now to solve the problem, take the help of the third relation, which is product of zeros is equal to minus 10. So alpha, beta, gamma is equal to minus 10. Instead of alpha, write A. Instead of beta, write A plus B. Instead of gamma, write A plus 2B, which is equal to minus 10. And substitute the value of A, which is equal to 2 minus B. And again in second bracket you will have 2 minus B plus B. And then in the third bracket you will have 2 minus B plus 2B is equal to minus 10. And B and B is cancelled. You will have 2 minus B, 2 plus B is equal to minus 10. So you will have 2 times 4 minus B square is equal to minus 10. 4 minus B square is equal to minus 5. And take minus 5 to this side, to left hand side. You will have 4 plus 5 is equal to B square. 9 is equal to B square. So you have two values of B, which is equal to plus minus 3. Now find the value of A. So when B is 3, A will be equal to 2 minus 3, and this is equal to minus 1. So you get the values. A is equal to minus 1, B is equal to 3. And again take B minus 3. Find the value of A by taking the help of first this equation. You will have A 2 minus 3 is equal to 2 plus 3 is equal to 5. So A is 5, B is minus 3. And you have to find the zeros now. Write the zeros. A plus B, A plus 2B. Just substitute the values. Instead of A, write minus 1. Instead of B, write 3. And you will get minus 1 plus 3, minus 1 plus 2 into 3, minus 1, 2, minus 1 plus 6. The zeros will come out to be minus 1, 2 and 5. Again write the zeros. A plus B, A plus 2B. Now substitute the value. A is 5, B is minus 3. So instead of A, write 5. Instead of B, write minus 3. Just you will get 5 minus 3, 5 plus 2 into minus 3, 5, 2, 5 minus 6. You will have 5, 2 and minus 1. So zeros in both the case, zeros are minus 1, 2 and 5. My next question is, if one of the zeros of the cubic polynomial x cube plus ax square plus bx plus c is minus 1, find the product of other two zeros. Let me explain the statement. First, note down, this is not a general cubic polynomial. This is x cube plus ax square plus bx plus c, which is not a general cubic polynomial. And its one of the zeros is minus 1. And we are to find the product of other two zeros. It means if alpha, beta, gamma are the zeros of this polynomial, so let alpha be minus 1 and we are to find the product of beta and gamma. Let alpha, beta, gamma is the zero of a quadratic polynomial x cube plus ax square plus bx plus c. So alpha plus beta plus gamma is equal to minus coefficient of x square upon coefficient of x cube is equal to minus a upon 1 is equal to minus a. And second relationship, alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x upon coefficient of x cube is equal to b upon 1 is equal to b. Alpha beta gamma is equal to constant term upon coefficient of x cube. It means it is equal to c by 1. It means it is equal to c. So alpha is equal to minus 1. It is already given to us. So I am taking the help of this first relation. Alpha plus beta plus gamma is equal to minus a. Instead of alpha, you will write minus 1. So you have minus 1 plus beta plus gamma is equal to minus a. Find the value of beta plus gamma by taking this minus 1 to the right hand side. So I have beta plus gamma is equal to minus a plus 1. Now take the help of this second relation. Alpha beta plus beta gamma plus gamma alpha is equal to b. So instead of alpha, you write minus 1. So it is equal to minus 1 beta plus beta gamma plus gamma minus 1 is equal to b. So minus beta plus beta gamma minus gamma is equal to b. So beta gamma is equal to b plus beta plus gamma. It means beta plus gamma is equal to minus a plus 1. So instead of beta plus gamma, I'll write minus a plus 1. So this is this is how you will find the product of other two zeros. Given that one of the zeros of the cubic polynomial ax cube plus bx square plus cx plus d is 0, find the product of other two zeros. Let me explain this statement. Now I have a cubic polynomial, general cubic polynomial, and it has three zeros. One is alpha, one is beta, one is gamma. And if 1 0 is equal to 0, it means if alpha is equal to 0, then I am to find the product of other two zeros. Now let me write it. Let alpha, beta, gamma are the three zeros of a cubic polynomial, and let alpha is equal to 0. Now I am going to write the relationship alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus t by a. I will take the help of this relationship alpha beta plus beta gamma plus gamma alpha is equal to c by a. So write alpha beta plus beta gamma plus gamma alpha is equal to c by a. Instead substitute the value of alpha, which is equal to 0. So instead of alpha you will write 0 into beta plus beta gamma plus gamma into 0 is equal to c by a. So this will become 0 plus beta gamma plus 0 plus is equal to c by a. So beta gamma is equal to c by a. So product of other two zeros is equal to c by a. Now my next question is, given that two of the zeros of a cubic polynomial ax cube plus bx square plus cx plus d are 0, then find the third zero. Let me explain this statement. I have a cubic polynomial and it has three zeros, alpha, beta and gamma. Two of its zeros are 0, means alpha is 0 and beta is 0. I am to find the third zero. So let me write it. Alpha, beta, gamma are the zero of a cubic polynomial, and alpha is 0 and beta is 0. So I'm going to write the relationship between zeros and coefficient. Alpha plus beta plus gamma is minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. Alpha beta gamma is equal to minus t by a. I'll take the help of this first relation to solve my problem. Alpha plus beta plus gamma is equal to minus b by a. Instead of alpha write 0, instead of beta write 0, and you will have plus you will have gamma here, and this is equal to minus b by a. So gamma is equal to minus b by a. Find a cubic polynomial with the sum of the product of its zeros taken 2 at a time, and the product of its zeros as 2, minus 7, minus 14 respectively. It means in this sum is equal to alpha plus beta plus gamma is equal to 2. This is given to us. Sum of product of its zeros taken 2 at a time. It means alpha beta plus beta gamma plus gamma alpha is equal to minus 7. This is given to us. And its product, which is equal to alpha beta gamma, is equal to minus 14. This is given to us. So I am to write a cubic polynomial. So write the formula for writing a cubic polynomial, which is fx is equal to k x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. Just substitute the values. You'll have k x cube minus 2x square plus minus 7x minus 14. So you will have cubic polynomial k x cube minus 2x square minus 7x plus 14.